Hi, in trigonometry, we can use our sine, cos, and tan ratios to solve trigonometric equations. Please make sure to learn these ratios and their reciprocals, as you will need them a lot in this course. To better understand how we work with these, let's look at some examples. Use a diagram and the given ratio to solve the following. If cos theta is equal to 1 over 3, find the value of sine theta plus cos theta. Now, before we can look at the equation, we need to draw in our diagram. Remember that sine, cos, and tan ratios only work with right angle triangles. So let's draw in a right angle triangle. Let's put in our right angle over here. Now you can choose either vertex for your angle, and we're going to put that down here. We don't have an actual value for the angle, so let's call it theta. Now we can name our sides. Let's draw a line from the 90-degree angle to the opposite side. This is our hypotenuse, and we can name it h. Now let's look at our angle theta and draw a line from theta to the opposite side of the triangle. Let's call this side O for opposite. The adjacent side lies next to theta, but it is not the hypotenuse. We already have our hypotenuse, which means that this must be our adjacent side. So let's call it A. The question tells us that cos theta is equal to 1 over 3. We know that cos theta is equal to the adjacent over the hypotenuse. So if cos theta is 1 over 3, then the adjacent side A must be 1, and the length of the hypotenuse must be 3. Let's put 1 into our diagram in place of A, and 3 in place of H. But we still need the length of the opposite side. We have the lengths of the hypotenuse and the adjacent side, so we can use Pythagoras to find the length of O. So we can say O is equal to the hypotenuse squared minus the adjacent side squared, all under a square root. Now we can fill in our values. We can say O is equal to the length of the hypotenuse, which in this case is 3, squared, minus the adjacent side, which in this case is 1. 1 squared is simply 1, so we can leave this as it is. And we put everything under a square root. Now we can square. 3 squared is equal to 9. Then we have minus 1 under a square root. 9 minus 1 gives us 8. And we see that O is equal to 8 under a square root. Let's put root 8 into our diagram as well. And we can make a note of it over here. Now we can make some space and look at our equation. Sine theta plus cos theta. We already have the ratio for cos theta. So let's make a note for sine theta, which we know is equal to the opposite over the hypotenuse. And now we can fill in our values. Sine theta is equal to the opposite over the hypotenuse. In this case, O is root 8, so we can say root 8 over the hypotenuse, which is 3. Then we say plus. Cos theta is adjacent over hypotenuse. Adjacent is 1 over the hypotenuse, which is 3. Here we have a common denominator, but without a calculator, we cannot add root 8 plus 1. So we simply say root 8 plus 1 all over 3. This is our answer. So let's do another example. Use a diagram and the given ratio to solve the following. If tan theta is equal to 2 over 3, find the value of cosec theta multiplied by sec theta. Again, we need to draw a diagram. So let's draw in a right angle triangle. Let's draw in our right angle over here. Let's put in an angle and call it theta. We know that our hypotenuse is directly across from the 90-degree angle. So let's put an H over here. The opposite side is directly opposite to theta. So let's call it O. and the adjacent side lies next to the angle, so let's call it A. Now we can look at our question. If tan theta is equal to 2 over 3, find the value of cosec theta multiplied by sec theta. Now, cosec and sec are reciprocal ratios, so before we do anything, let's write down our three original ratios, sine, cos, and tan, and our reciprocal ratios, cosec, sec, and cot. Tan theta is equal to the opposite over the adjacent, and in this case, tan theta is equal to 2 over 3. That means that in this example, the opposite side O is equal to 2, and the adjacent side A is equal to 3. Let's put 2 in our diagram in place of O, and 3 in our diagram in place of A. Now we still need the length of the hypotenuse. We have the length of the adjacent side and the length of the opposite side. So now we can use Pythagoras to find h. So we say h, the hypotenuse, is equal to the opposite side squared plus the adjacent side squared, all under a square root. And now we can fill in our values. So we say h is equal to the opposite side, which in this case is 2, squared, plus the adjacent side, which in this case is 3, squared, all under a square root. Now we can square our values. 2 squared gives us 4, plus 3 squared, which is 9, all under a square root. 4 plus 9 is equal to 13. So we can see that h is equal to 13 under a square root. Let's make a note that h is equal to root 13 up here, and we can put root 13 in the place of h on our diagram. Now we can clear this up and look at our equation. Cosec theta multiplied by sec theta. Cosec theta is equal to the hypotenuse over the opposite side. Our hypotenuse is root 13, so we can say root 13 over the opposite side, which is 2, multiplied by sec theta, which is the hypotenuse over the adjacent. Our hypotenuse is root 13 over the adjacent, which is 3. Now we can multiply our values together. Root 13 multiplied by root 13 becomes root 13 squared. The square and the root will cancel, and we're left with 13 over 2 multiplied by 3, which is 6. Let's do another example. If cot theta is equal to 1, find the value of 1 plus sec squared theta. Now, you don't need to draw a diagram to solve these equations as long as you know your basic trigonometric ratios and their reciprocals. So if the question does not ask you to draw a diagram, it is up to you if you want to draw one or not. So in this example, we are not going to draw a diagram. Let's look at our question. Cot theta is equal to 1. This is one value, and we know that the value for every trigonometric ratio comes as a fraction. But remember that any whole number can be written as a value over 1. So let's make a note of this, and we can say cot theta is equal to 1 over 1. We know that cot theta is equal to the adjacent over the opposite side. In this case, cot theta is equal to 1 over 1. So in this example, the adjacent side A is equal to 1, and the opposite side is equal to 1. Our question asks us to find the value of 1 plus sec squared theta. Now, sec theta uses the ratio of hypotenuse over adjacent. So before we can solve this equation, we need to find the value of h. We have values for our adjacent and opposite sides, so we can use Pythagoras to find h. And we can say h is equal to the adjacent side squared plus the opposite side squared, all under a square root. Now we can fill in our values. We can say h is equal to the adjacent side, which is 1, squared, which is still 1, plus the opposite side, 1, squared, which is also still 1, all under a square root. 1 plus 1 is 2, and we see the hypotenuse is equal to root 2. Let's make a note of this, and now we can tidy up our screen. Now we can look at our equation, and we say 1 plus, we're working with a squared term, so let's open a bracket. Sec theta is equal to the hypotenuse over the adjacent. Here our hypotenuse is root 2, so we can say root 2 over the adjacent, which is 1. Let's close our bracket and square it. Now we have 1 plus root 2 squared, which is simply 2, over 1 squared. So we get 2 over 1, which is simply 2. Now we have 1 plus 2, which gives us an answer of 3. Let's do one last example. If 13 cos A is equal to 12, find the value of sec A plus sin A. Now, in our earlier videos, we said that in order to find the value of a trigonometric ratio, the ratio has to be by itself on one side of the equal sign. So let's start by getting cos A by itself. And to do this, we divide both sides by 13. 13 cos A over 13 leaves us with cos A, which is now equal to 12 over 13. Cos theta is equal to the adjacent over the hypotenuse. And in this case, cos A, our angle, is equal to 12 over 13. So now we can see the adjacent side A is equal to 12, and the hypotenuse H is equal to 13. Now we can use Pythagoras to find the length of the opposite side. So we can say O is equal to the hypotenuse squared minus the adjacent side squared, all under a square root. Now we can fill in our values. We can say O is equal to the hypotenuse, which is 13, squared, minus the adjacent side, which is 12, squared, all under square root. Now we can square our terms. 13 squared is 169, minus 12 squared, which is 144, all under a square root. 169 minus 144 gives us 25. So now we have 25 under a square root. The square root of 25 is 5. So we know that O is equal to 5. Let's make a note of this, and we can clean up our page. Now we can look at our equation, sec A plus sin A. Sec theta is equal to the hypotenuse over the adjacent. Our hypotenuse is 13, so we can say 13 over the adjacent, which is 12, plus sine theta opposite of hypotenuse. In this case, our opposite is 5, so we can say 5 over the hypotenuse of 13. Now, in this case, the denominators of these fractions are not the same, so we need to find a common denominator. The lowest common multiple of 12 and 13 is 156, and we get to this value by multiplying 12 and 13 together. So let's multiply our first fraction by 13, and we can say 13 multiplied by 13 is 169 over 12 multiplied by 13, which is 156, plus, for our second fraction, we need to multiply both top and bottom by 12. 5 multiplied by 12 gives us 60 over 13 multiplied by 12, which is 156. Now we have a common denominator, and we get 169 plus 60 is 229. And we can see our final answer is 229 over 156. This fraction cannot be simplified, So this is our final answer.